In this question, an electric motor pump is 60% efficient and is rated 2.5 horsepower. Calculate the maximum load it can lift through a height of 10 meter in 8 seconds. So here 1 horsepower value is 750 watt. So if you understand this question with a figure, as you see in this figure, here we have electric motor, and this electric motor taking the electrical energy, and this electrical energy is converted to potential energy. So when this electric motor is taking the electrical energy, this motor has to require some power. And then when it is doing the potential energy, this electric motor also needs some power. So we can say that we have two different types of power. One is power input and another is power output. So according to the question, the efficiency of this electric motor pump is 60%. It means that if, let's take example, if we are supplying 100 watt of power input, so it will convert to 60 watt of power output. So now according to the question, already 2.5 horsepower is considered as the power input. So 2.5 horsepower we can write in term of watt by multiplying with 750 watt, means 1 horsepower is equal to 750 watt. So we get it as 1875 watt. So this is the total power input in watts. Now what will happen if we have to find the power output? So why we need to find the power output, that is also a question, because we have to find the maximum load. So maximum load means what? See, when we use the electric motor, it will start throwing out the water, and this water will reach to a certain height which is given as 10 meter. As we know that if there is a water, so it must have certain mass. So we have to find what mass of water this system or this motor can hold if it reaches to the height of 10 meter. So what we have to do in this question, we have to basically first find the potential energy, because if we find the potential energy, we know that potential energy is m into g into h. Mass is not known, that we have to find. G already we know, we can take it as 9.8 meter per second square, and height is given as 10 meter. So these all things are known, only two are unknown, which is potential energy value and the mass value. So first we have to find the potential energy. So to find the potential energy, we need to find the power output. So for finding the power output, we need to use the efficiency formula. This is a symbol called as iota. It is used for efficiency. So efficiency is equal to power output divided by power input. Efficiency is, according to the question, it is 60%. So we can write 60 by 100. Power output is unknown, so we can write it as x. Power input is 1875. So if we solve it, this 0 can be cancelled. So x is equal to 0.6 into 1875. So x is equal to 1125 watt. So this we got it as power output. Now we know that power is equal to work upon time. So what is the work here? This work is actually potential energy. So potential energy is equal to power into time. So power we can write it as 1125, which is the output power, into the time is 8 seconds. So we can multiply this value with 8. So it will come around, potential energy is equal to 9000 joule. So now we got the potential energy. So after getting the potential energy, we can use the formula. Potential energy is equal to m into g into h. Potential energy is 9000, mass is unknown, g is 9.8, and the height is 10 meter. So m is equal to 9000 upon 98. So it will come approximately 91.84 kg. So this is the answer of this question.